So what you will call the binary code as? You will call 0 and 1. The combination of zeros and ones is what I will call it as a binary code. And how do we write the octal number? Octal number, it's a combination, or it's in the range of 0 to 7. We don't have 8 and 9. Hello everyone, I welcome all of you to the first session on data representation. What exactly I will be learning in this chapter? So, please understand, computer will understand only the language of zeros and ones. Whatever the instructions that you are giving, whatever the data that you are passing, everything will be treated as a zeros and ones. When this is the case, how exactly we are trying to manage with only zeros and ones? So to understand this in a clear way, so we have the chapter called data representation. So guys, in this chapter, we will be understanding the different types of number system that we have to represent our data. Without wasting much of your time, let me get into the session. So what is that I will be discussing in this session? So guys, I'll be discussing the brief introduction with respect to this chapter, followed by I have two categories of number system. The first one that I have is non-positional number system. I'll not be discussing much in detail with respect to this topic because you don't have much detailed syllabus with respect to non-positional number system. But we will be discussing in detail with an example with respect to positional number system. Under this positional number system, we have four different types of number system. The first one that we have is decimal number system. How exactly we will be representing the decimal number is what we are trying to understand in this number system. In the same way, I have three more number system, that is binary, octal and hexadecimal number system. I will be demonstrating each and every number system with a problem, so which will help you to understand this number system and the different conversions that we have in the number system. So without wasting your time on the introduction, so let me get into the concept. What is the basic thing that I should know before I start this chapter? So what is the first point that I need to understand? Please observe here. So in the digital computer, you have your data and you have your instructions. All the data and instructions are stored in the computer in the form of zeros and ones. So I will call that zeros and ones as binary code. So what you will call the binary code as? You will call 0 and 1. The combination of zeros and ones is what I will call it as a binary code. So I will also call this binary code as machine code. So all my instructions, all my data is in the form of binary code or is in the form of machine code. That is the first point that you need to understand. So fine, I know that all the data that I have here is in the form of binary code and machine code. Alright, so what is the second point that I should observe here? Please understand, I spoke about the data. What you will have in your data? I will have alphabets. I will have numbers that I will call it as a digits. I will have special characters. All these things, whatever I have, please make a note of it. All these things, whatever I have, all these things are represented in the form of binary code. To represent all these things, I have one more special thing that I will call it as a number system. When it comes to number system, so I will be using the digits. To represent all these things. That is the basic knowledge that you should have before I start this chapter. So what is that you should have when I complete this slide? Everything the computer will be understanding in the form of machine code. That is the first point that you should understand. So whenever I speak about the data, numbers, characters and the special characters, please remember all these special characters are converted into the machine code, or I will also call it as a binary code. So that's very important that you need to remember. So fine, so I understood the basics. What next? So when it comes to the next concept, please understand, as I discussed in the introduction, so we have two types of number system. As I told you in the previous slide, I will be using the number system to represent all this data, instructions and everything, right? Then how many categories of number system I have mainly? When it comes to the categories of number system, I have two types of categories. The first one is non-positional number system. What is the first one that we have? The first one is non-positional number system, and the second one that I have is positional number system. So what exactly positional number system and non-positional number system is all about? Let's understand this one by one in detail. Let's start with the non-positional number system. When it comes to the non-positional number system, so I can just give you a simple example. We were using the Roman numbers. So this Roman number, say for example, so this is what I will call it as a Roman number. This represents 1. The same way this represents 2. The same way this represents 3. So this is what I will call it as a Roman numbers. So this I was using and I was calling it as a non-positional number system. Basically, I cannot perform most of the arithmetic operations with respect to non-positional number system. So that was the major drawback that I have. So this is what you need to understand with respect to non-positional number system. So you understood what is non-positional number system. Non-positional number systems are nothing but the Roman numbers, and I was not able to perform, and still I will not be able to perform most of the arithmetic operations if I am using Roman numbers. So how do I solve this problem? So fine, what is the next number system that you have to overcome from all this drawback? So I have the next number system, as we all discussed in the previous slide, that is positional number system. When it comes to the positional number system, so inside this positional number system, we have 4 different types of number system. The first one that I have is decimal number system. The second one that is binary number system, and the third one is octal number system, and the last one is hexadecimal number system. Please make a note of it. When it comes to the category of positional number system, we have 4 different types of number system. The first one is decimal number system. Second one, I repeat for all of you, please make a note of it. It's very important. The second one that we have is binary number system, and third one is octal, and the fourth one is hexadecimal. So what is that I'm going to do in this session? I will be discussing each and every number system what I have in the positional number system in detail. So let's start with the first one that I have, decimal number system. So what exactly decimal number system is all about? Let's understand one by one in detail. So what is the first point that we have? It is most widely used number system. Now all of us know. When did you explain that, sir? I will explain what exactly the decimal number system is all about. Then you will tell me that, yes sir, we have understood and we all know that it is widely used than we compare to all other number system. So fine, let's get into this. What exactly decimal number system is all about? So in this decimal number system, so you will be using the numbers from 0 to 9. So what is this 0 to 9, sir? Any combination from the number 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So combination of these numbers, this is the range of decimal number system. Combination of these numbers, I will call it as a decimal number. So can you give me an example? Yes. So can I write 149? Can I write 149? Sir, do I have 1 in this range? Yes, of course I have. Do I have 4 in this range? Yes, I have. Do I have 9 in this range? Yes, I have. So then every number, whatever you are writing, so can I call it as a decimal number system? Of course, you can call it as a decimal number system, but make sure that the base of this number is 10. Only then you will be able to call that as decimal number system. Hope you understood. Decimal number system in the sense any combination of numbers from 0 to 9 you can write, but make sure that only when I write the base as 10, only then I will call that as a decimal number. I will call that as a decimal number. This is what you need to understand with respect to the decimal number. All right, then what is the next one that I have? The next number that I have is binary number. Before that, let me give you some of the examples. So I have 456. Can I have 456 as a decimal number? Of course I can have, because 4 is in the range, and then I have 5. 5 is in the range. I have 6. Again, I have 6 is in range. So do I have the base 10? Yes, of course I have. So can I call this as a decimal number? Yes, it holds good. It's correct. You can call it as a decimal number. In the same way, I have 7,890 to the base 10. So can I call? Yes, of course you can call. So this is how you will be representing the decimal numbers. All right. So moving on to the next one, that is binary number system. What exactly binary number system is all about? Let's have a quick look. I have binary number system. In this binary number system, please understand, so digital computer represents all kind of data. Please understand, this is very important. All kind of data, whatever I have, so it can be data and also it can be information. So please have the clear difference between the data and information. All right. So data is different, information is different. All these things I will be representing in the form of binary system. Whatever you have, okay, whatever you have inside the system, everything will be represented in the form of binary number system. What exactly binary number system is all about, sir? So when it comes to decimal, okay, when it comes to decimal, you told it's a combination or it's a range between 0 to 9. But when it comes to binary, so you should remember, I just have only 2 digits. So that is 0 and 1. Binary number is a combination of zeros and ones. Binary number is a combination of zeros and ones. That's what you just have to remember at this point of time. Then how do I represent the numbers with the help of binary numbers? So I will be speaking about that. So just wait until I come to the calculation part. As of now, you just have to remember, so binary numbers in the sense, it's a combination of zeros and ones. But, sir, for example, you said zeros and ones, all right? If I write 0110, okay, I have just taken the number. Can you call this as a binary number? No. Why? Because you have not mentioned the base for this number as 2. What is the base of this number? When I'm discussing the binary number, you should never forget to write 2 as a base for this number. That's very important. That's very important. All right. So only when I mention the base, only then you will call this as a binary number. This as a binary number. So let's take one more example. Say for example, I have 0117 to the base 2. All right. So can I call this as binary number? No, I cannot, because 7 is not in the binary number. So that's what you need to remember. Let's take one more example. 0001, okay, to the base 2. Can I call this as a binary number? Of course, you can call this as a binary number, because both are 0 and 1 are in the range. So this is how you should be able to identify whether it is a binary number or not. So fine. So you understood the brief knowledge. You got a brief knowledge about the binary number system. What next? So we have the octal number in the next concept. What exactly this octal number system? As we discussed, we all know that decimal in the sense 0 to 9, okay? Binary in the sense 0 to 1. So that's a combination, 0 and 1. The next one, octal. Octal in the sense 8. What should come to your mind? Octal in the sense 8. So I will be starting the number from 0. This is octal, okay? So I will be starting the number from 0 to 7. I will have the number 0 to 7. Please count. I will start from 0, 1, 2, 3, 4, 5, 6, 7. All right. How many numbers I have? So please count. This is 1, 2, 3, 4, 5, 6, 7, 8. So how many numbers I have? So I have 8 numbers. That's why I will call it as a octal number. That's why I will call it as a octal number. So fine. So decimal number, you told any combination of this number and the base 10 is decimal number. Any combination of zeros and ones, you told it's a binary number. Then how do I represent this octal number, sir? Yes, within this range, if you are able to represent, so then I will call that as octal number. So let's take a try. Let's try and understand this with an example. Say for example, I will write 456 to the base 8. Can I call this as an octal number, valid octal number? Yes, of course. Why? Because 4 is in the range. Do I have 4? Yes, I have. So I have 5. So do I have 5? Yes, I have. So do I have 6? Yes, I have 6. But I should make sure that the base of this octal number is 8. That's what you need to remember at this point of time, my dear students. So fine. We understood the concept of octal number. Let's take one more example. Suppose if I write 879 to the base 8. Sir, can I write the octal number like this? Is it a valid octal number? No, it is not valid octal number because yes, of course 7 is in the range, but where is 9? I don't have 9. So again, it is not a valid octal number. Suppose if I write, so fine, okay, so 343. Will it be a octal number? No, because you have not mentioned the base for this number. So that's what you need to remember at this point of time. It's very important that you should never miss out to write the base of that particular number. Alright, so you understood the concept of octal number. So the range of this octal number starts from 0 and till 7. Any combination of 0 to 7 you can write, but make sure that you will write the base as 8. So then only you will be called, then only you will be understanding it, or then only you will be calling that as an octal number. Then what is the next one that I have, sir? I have the hexadecimal. So octal in the sense 8, hexadecimal in the sense 16. So let's understand that how exactly I will be having. So we understood, so we have decimal 0 to 9. We have binary 0 and 1. We have octal 0 to 7, hexadecimal in the sense 0 to 9. I have till 9. Then how do I write A? How do I write 10 then? So guys, I have A. So A will help me to represent the equivalent value of 10. So instead of 10, I will be writing A. So please understand, imagine I have 10, 11, 12, 13, 14 and 15. So what is the equivalent of 10? So instead of 10, I will be writing A. So instead of 11, I will be writing B, C, D, E and F. This is how I will be writing. Suppose if I want to represent 14, so instead of 14, I will be using E. That's what you need to remember. This is how I will be representing the hexadecimal. Let's take an example. Say for example, I have given here A, B, C, D, E, F. So please understand. So this is how I will be representing 10, 11, 12, 13, 14, 15. So please understand, if I start any number from 0 till 15, so how many numbers I have? So in total, I will be having 16. I will be having 16. That's what you need to understand. That's what you need to understand. So for example, I'll take, I need to represent 10, okay? I need to represent 10 and I need to represent 11 and I need to represent 12. Okay, this is what I need to represent in hexadecimal. How do I represent in one number? So what is the equivalent of 10? So equivalent of 10 is A, B, C to the base 16. A, B, C to the base 16. Can I call this as a hexadecimal number? Yes, of course you can call this as a hexadecimal number. But so suppose if I write like this, don't you call this as a hexadecimal number? Of course I will call this also as a hexadecimal number, but I will not treat this as a 10. Instead, I will treat this as 10, 11, 12. That's what you need to understand. That's the major difference that you need to make a note of it. Alright, so please, my dear students, pay some attention here to understand the concept of hexadecimal. So we have the range from 0 to 16. Is it? No. 0 to 15 because I'm starting it from 0. So total I have 16 numbers. So if I start from 0, obviously I'll end by 15. So, but the main thing that you need to remember is I don't have 10, 11, 12, 13, 14, 15. So instead of that, the 10 is what I'm starting with A and ends with F. That's what you need to remember. So instead of these numbers, I will be using these alphabets. So this is what you need to remember with respect to hexadecimal, and the base should be 16. The base should be 16 is what I would like to stress again here. So let's have a comparison table. I have a table with me. So let me show you the table to understand this concept much better. So I have 4 number systems here. So hope you are able to see this. I have 4 number systems. So please understand, I have decimal. So for the decimal, the base is 10. What is the decimal base? So it's 10. So please understand the base of binary, that is 2. And when it comes to octal, the base is 8. And when it comes to hexadecimal, the base is 16. This is very important to remember. So I have 1. Okay, I have 1. So when I take 0, it's same. I will be representing, or I'll be writing 0 in all the number system as 0 itself. So let me not discuss about it. So when I take 1, how do I represent 1 in the decimal number system? Obviously it is 1. So same thing in the binary, same thing in the octal, same thing in the hexadecimal. But the picture starts from here. Let me explain 1. And the rest, everything, so I will give you an assignment for all of you. You consider this table and you start trying out how exactly we are trying to represent. All right. The second one, so I will be writing 2 as it is. When it comes to decimal, there is no conversion because normal numbers we will be using. So I have taken 2. How do I represent this 2 in binary is what we need to understand. So please observe 2. How do I represent 2? When it comes to binary is what I'm showing you now. So when it comes to binary, please make a note of it. So I need to represent 2. How do I write it? So please understand, I will be using 2 to the power of 0 into 1. So 2 to the power of 0 is what? 2 to the power of 0 is what? 1. Right? 2 to the power of 0 is 1. So fine. 2 to the power of 1 into 1. So 2 to the power of 1 in the sense what? 2 to the power of 1 is 2. So fine. Now, if you take this equation, so let's calculate now. So 1 into 2, so how much you get? So 2. So 1 into 1, how much you get? 1. So it is 3. Right? But how much I need? I need 2. So to get 2, what is that? I should make it as 0. This one or this one? So I will make this one as 0. So what will be my equation now? Please understand. So 1 into 2 to the power of 1. 2 to the power of 1. Okay. So let me just take a pen. Sorry. So 1 into 2 to the power of 1. So 1 into 2 to the power of 1 is 2. So 1 into 2 is 2 plus. So 0 into anything is 0. So how much I got? 2. So my answer is 2. So I got 2. Now how do I represent in binary? So please consider this number. So how much you have? So you have 1. How much you have here? You have 0. So how much you got? 1 0 to the base 2. 1 0 to the base 2. Do I have 1 0 here? Yes, I have. This is how I convert the decimal number to binary. Decimal number to binary. This is what you need to understand. I will show you one more. So how do I convert 3? 3 we have already seen. Let's take it for 4. How do I convert 4? How do I write the binary equivalent for 4? So this is what I should get. Okay, how do I get it? Let's try and understand. So 2 to the power of 0. From 2 to the power of 0 itself, you should start always. So fine. So I will, by default, I will take it as 1. So 2 to the power of 1 into 1. 2 to the power of 2 into 1. Let's assume like this. So 2 to the power of 0 is basically 1. So 1 into 1 is 1. Okay, fine. So 2 to the power of 1 is 2. So 1 into 2 is basically it's a 2. So already I got 3. Alright, I need to have 4. So fine, 2 to the power of 2 is 4. 1 into 4 is 4. I just want only 4. I don't want this 2. So what is that I have to do? So I will make this as 0. This is a shortcut that I'm helping you out with. Right? So how do you write the binary number for 4? So I want the binary number for 4, right? So what is that I have to do now? So 1 into 4 is 4. 0 into anything is 0. 0 into anything is 0. Now I got 4. My answer is 4. Now I need to convert this into binary. Then how do I take the binary number? So please consider this numbers again. So what is the number you have? 100 to the base 2. So do I have 100 to the base 2? 4. This is how you will be converting. This is how you will be converting the decimal number to binary. Alright. So in the same way, I have octal number. I have already told you. So you have the range from 0 to 7. So you don't have 8 and 9. So you'll not be using that numbers at all. So you don't have 8 and 9. Again, I have 10 to 17 I have. I don't have 18 and 19. Again, I'll have 20. Okay, from 20 onwards it will start. So this is how I will be representing the octal number. But please observe when it comes to hexadecimal. So please understand, I have 0 to 9. Okay, I have 0 to 9. I don't have 10 here. So what is that 10 equivalent? So 10, instead of 10, I will be writing A. Instead of 11, I will be writing B. So it goes on till F. So this is how I will be having the 4 different number systems. Okay, this is very important that you need to understand the 4 different number systems. So fine, we understood the 4 different number systems. So we also understood how do we represent binary numbers. How do we convert the decimal to binary? We understood that. And how do we write the octal number? Octal number, it's a combination, or it's in the range of 0 to 7. We don't have 8 and 9. So again, it starts. That also we know. And obviously, hexadecimal, total 16 numbers. So we have 0 to 9. So 0 to 9 we have. Then we don't have 10. Instead of 10, we have A to F. So we understood this. What next? Now, how many number system we have? We have 4 different number systems here. In the positional number system, we have 4 different number systems. So we need to understand how to convert all these numbers. What exactly it means? Let's understand this. I have a decimal number. Okay, I will write it as D. Then I have binary number. I have octal number, and I have hexadecimal number. So in total, I have 4 different number systems. In total, I have 4 different number systems. Now I need to check how many conversions that I can perform. What is that, sir? Can I convert decimal number system to decimal number system? Of course you can convert, sir, but the answer is same. Yes, consider that as a 1 conversion. Can I convert decimal number to binary number? Yes, you can convert, sir. So decimal number to binary number. Fine. Can I convert decimal number to octal? Yes, you can convert. Can you convert decimal to hexadecimal? Yes, of course you can convert. So how many conversions I have? Total 1, 2, 3, 4. So I have 4 conversions. How many number systems I have? 4. So 4 into 4, total 16 conversions we can perform. 16 conversions, 16 combinations of conversions we can perform. Here is what you need to understand. That's what I'm going to discuss in the coming classes. Alright, so guys, so with this, I have come to an end of this session. So please understand the basics of number system, and please take care of your health and take care of your family, respect your parents. So by saying this, thank you, bye-bye.